Hi, this is the fourth video of Algorithm Design Manual, and just as a follow-up from the last video to conclude, I want to say that solving real-life problems is no longer about having breakthroughs in your algorithms or new innovation, because it's not about creating the next Dijkstra algorithm, for example. The hard part, and this is the most fruitful part, is about finding the pattern of your problem. And through finding that pattern, then you will find the best solution that already exists for that problem. Because most of the problems that we have has already been solved in an abstracted way. We just need to find the most suitable solution for our problem through those resolutions that exist. And the book does really a good job by developing a good skill, which is pattern recognition through the problems that you you will tackle or you will find. And he does it through a quantitative approach by sharing multiple problems that's, or let's say real life problems in very different types or sectors. And he shares like an explanation or just a general idea how it is resolved. And most of the time it is just finding the basis algorithm to use through those algorithms. And I just want to share a personal take of that pattern recognition skill, just to give you a concrete example. And for example, when you solve a problem, you just at first you identify the objects that it is using, and that will help you to know what data type to use. Are they strings? Are they graph nodes? Are they edges? What can we represent them the most in our algorithm? Then you try to find the relationship between those objects in your problem, and that will help you find this data structure that you use. And sometimes a big part of the base algorithm that you will use also. Is it like a tree? Is it a cycle that's going to be a graph? Is it a map that should be implemented as a graph? Are there unique elements that can be described in a dictionary, which is a tree? And then you're going to find the abstracted goal of that problem that we're having. And what I mean by abstracted goal is the problem going to saying to reach this graph node, for example? Then it is automatically a depth first or a, a breadth first search that you're going to do. Uh, is it about finding the first element or the last element or the minimum element? Then you're going to have make sure that your data structure is going to be ordered. So you're going to order that data structure before searching through it. And is it about finding the minimum cost or the maximum cost? So these questions is what helps you to find the basis algorithm of your problem. Another aspect that you should be careful on is what is the scale of the input? Is it just between 20 to 30 to 40, or is it between 100 to 500, or is it like way more in the thousands or 10,000s? And that really depends on how you're going to use the algorithm or the base algorithm that you're going to choose. Because if it is just in a small amount, then you just can frost brute it. You don't need to go in a complex way. But if it is in the high scale, then you need to go with the more complex algorithms that will resolve it in a logarithmic way or in a linear way. And also there is one more thing in this is it's not about just finding the suitable problem, but sometimes, like I said in the last video, it saves you the cost of trying to find a solution that doesn't exist. For example, for problems that are NP hard or NP hard. So you need to be careful on the analysis of your problem rather than just finding the solution in a arbitrary way. And that's pretty much it for this video, because the book was just about sharing a catalog of the problems, and I don't want to go share a specific solution of a problem because that will drift away the point of my video. And I just want to keep it summed up. And yeah, thank you for watching.